So after all of this definition, let's go to some of the real examples. In this example, it illustrates an idea that, well, efficiency is not everything, okay? If we would like to have higher efficiency items, we may sometimes need to pay more cost in this case. So in this example, we will talk about this, okay? So this is example 2.14 from the textbook. There's a cost of cooking with the electric and gas ranges, okay? There are two kinds of ranges that we will use in cooking. Generally, we will have electric as well as gas ranges, okay? Well, the efficiency of cooking appliances affects the internal heat gain from them, since an inefficient appliance consumes a greater amount of energy from the same task, okay? And you should have an idea that if the efficiency is lower, then you should have a greater input to have a same output as defined as the definition in the efficiency. And the excess energy consumed will show up as a heat in the living space. Okay, all of them will be dissipated as heat and other kinds of energy losses. The efficiency of open burners is determined to be 73% for electric units and 38% for gas units. Okay, consider a 2 kilowatts electric burner at a location where the unit cost of electricity as well as the natural gas will be this two value, $0.09 per kilowatt hour as well as 1.20 therm. One therm is 105500 kilojoule. Okay, I've stated that here. And we need to determine the rate of energy consumption by the burner as well as the unit cost of the utilized energy for both electric as well as the gas burners. Okay? So we need to find out the rates of energy consumption. Okay, how can we find out? Well, this 2 kilowatts is the energy input required. That means you need to input 2 kilowatts of power for it to operate. So we will have a Q dot utilize to be 2 kilowatts multiply the efficiency, 73%. Okay, 73%, so that we get the output, so 1.46 kilowatts, correct to 3 significant figures, okay? First of all, we will get the Q utilized, that's the power output, okay? So how about the cost? The cost of this utilized energy. Well, in order to find out this cost, well, because we know that this cost is inversely proportional to the efficiency. Okay, as we know that if we would like to supply this amount of kilowatts, that's 1.46, then actually we need to input 2 kilowatts. Okay, so we will see the cost should be inversely proportional to the efficiency. Okay, so we will have 0.09 per kilowatt hour divided by 73%. And that's the cost of the utilized energy. Okay, well, it is actually the cost of the energy input per kilowatt hour, so that it will become 0.123 kilowatt hour, correct to 3 significant figures. Okay, got it? Okay, but how about the gas? Well, first of all, we need to find out the input first because we need to find out the energy consumption. Okay, well, we have the energy output already. That is the amount of energy that we need to supply. We can use this to find out the energy input by using this gas range. Is equal to 1.46 kilowatt hour divided by 38%. So that we can find out the energy input required. So this power input should be this one. Okay, let me use a calculator. 1.46 divided by 38%, that's 0.38. And we get this one, 3.84. Okay, 3.84 kilowatts. Correct to 3 significant figures. Okay, how about the cost? Well, the cost, as I've said, that it is inversely proportional to the energy efficiency. But note that for the natural gas, the cost should be 1.20 per therm. Okay, per therm. Well, if we would like to do a comparison, we need to homogenize the unit first. We need to make the units the same. For example, here we have used kilowatt hour. Okay, either we convert all of the units to per therm or to per kilowatt hour. Let us do some conversion here. So 1 therm, as we have set it, equal to 105500 kilojoule. How can we convert this to kilowatt hour? Easy. We just divide this one by 3600 so that we can find kilowatt hour. Okay, because 1 hour is equal to 3600 seconds, so we have a joule per second, and then it can become kilowatt. And then we can do this 105500 divided by 3600, we get this 29.3. Okay, let me take one more value. So it becomes this 29.31. And let us find out the cost. The cost should be 1.20 per therm, so 29.31 kilowatt hour. Okay, that's one term, divided by the efficiency, so 38%. And we will get the corresponding value, so it will be 1.20 divided by this, and then divided by 0.38, and we can get this. This is 0.108. Correct to three significant figures. Okay, so we get this. Well, as a comparison, although the efficiency of open burners, okay, has a higher efficiency than the natural gas burner, but you can see that the energy cost is higher than that. Okay, the energy cost is higher than that. Okay, well, it seems to be contradicting to our understanding, but after some calculation, we have verified this. Is that, well, although we need a higher input, but because the natural gas is much cheaper than the electricity, so that we can use less money to satisfy our energy needs. Okay? There are so many factors regarding efficiency, so we need to analyze the case more comprehensively. Okay? Okay, next we will talk about some efficiency of different mechanical and electrical devices. Okay?